Okay, so when you get your machine, one of the first things that I'm going to want you to do is to calibrate your kerf width. And the way that you do that is you start off by looking at your manual and finding out what the kerf width is supposed to be per the manual. And so right now I'm going to the Hypertherm manual, and I'm seeing that for 10 gauge material, that our kerf should be 0.041. So let's just get that entered in, 0.041. Oh, 0.041, enter. Now we have that entered in, and I'll show you why I picked that here in a second. So in order to calibrate this, what I want you to do is go over to the miter screen, and I provided with the machine, a section of pipe that is 1 inch schedule 40. And the outside diameter of that pipe is 1.315 inches. The inside diameter of that pipe is 1.049 inches. Okay. I want you to cut a section of pipe that is 3 inches long, and I want each side to be 90 degrees. So this, as we've talked about in earlier videos, when you're on the miter tab, the diameter of the pipe you're cutting into is irrelevant because you're cutting into a flat surface, not a pipe. And so these could be whatever you want, but for the angles, oh, and you see a mistake that I made right there. I entered in something, I entered in 90, and then I clicked to the next box, but it reverted back to what I had entered in before. What you need to do is enter in the number and then hit the enter button in order for it to take every time. So pipe diameter 1 doesn't matter. I want the other angle to be 90 degrees as well. Pipe diameter 2 doesn't matter, and rotation doesn't matter. Okay, so what are we going to test here? We're going to test a pipe, 1 inch sked 40 pipe. We're going to cut it 3 inches, and it's going to be a 90 degree cut on one side, a 90 degree cut on the other side. And then what we're going to do is we'll cut that out, and we will measure it and use that measurement in order to determine what length, what this kerf should actually be. So back over the miter, we have all of our information entered here, and we're going to calculate the G code, and let's call this kerf calibration. Yes, I spelled that right. Okay. And we go over here. We see that it's already loaded. We're going to come in. We're going to zero everything out. And now let's go to the machine. As you can see, we have a piece of pipe in the machine. We've moved everything to 0, and now we are ready to start our first cut. So we've gone into the office and we've measured this pipe, and what we've come up with is a measurement of 2.9605. For the purposes of this exercise, we're just going to call that 2.96. What we'll see later is that what I did here in terms of measurement is not necessarily the most accurate way to measure a piece of pipe coming off the pipe processor, and we'll have a better method here coming up shortly. Okay, so we cut this pipe. The intention was to cut a pipe to 3 inches after accounting for a kerf of what was in the book, which is 0.041. We mic'd that pipe and it did not come out to it did not come out to 3 inches long. Let's go here to the calculator. We were going for 3 inches long. It mic'd to 2.96 inches long. So a little bit more than a 30-second short. So the kerf, if this were 0, the kerf would be 0.04. But of course, this was not 0. This is 0.041. So we've got to add this in to the equation. And so we're going to add 0.041, which equals 0.081. Okay, so the new number we're putting in here, 0.081, enter. The new number that we're putting in here is 0.081. And the reason why that's so much bigger than what's in the book is probably because I'm running the machine as slowly as I am. I'll be honest, I think I'm running it too slowly. There was actually kind of a lot of dross stuck to the inside of that pipe, and I think that if I sped it up a little bit, some of that dross would be eliminated. But for the purposes of this, I'm going to leave the speed rate alone, and we can dial that in. The point is that this kerf width, okay, really, we're calling it kerf width, but the reality of the situation is what we're trying to do is calibrate or dial in the last 32nd, the last 1/32 of an inch for this machine. And to get it, to within a 32nd of an inch, we can use math and spreadsheets and tape measures, but really to dial in that last 32nd of an inch, okay, that is really dependent upon your plasma torch, the speed that you're running, a bunch of different factors. And so what we're doing here with this kerf width data entry point, it's more than just trying to figure out what the kerf width is, okay? It's to dial in the last bit of calibration that's needed on this machine. So we've put in the revised kerf width. Someday I'll be able to say that easily. Let's go over to the miter tab, and we're going to leave all of these parameters the same, but we have to recalculate because we made a change to these parameters right here. So we'll come over to the miter, we'll calculate, and let's call this kerf calibration 2. Incidentally, this doesn't check to see whether or not the file exists. So you want to be real careful when you name these files. I'm pretty sure I have a file already saved called Kerf calibration 2. It doesn't care. It's just going to overwrite that file. So keep that in mind when you do that. It's not like your Microsoft Excels, which will check to see that there's nothing already named. This one is just going to override it. At any rate, so we click OK. We have the new G code generated. We go over here. I'm just going to rewind that back to the beginning. Everything's zeroed out. Let's go over to the machine. Okay, so I'm not going to take the time to show you all 5 of these cuts, but basically in the first video at the machine, you saw us cutting pipe 1. The second video at the machine, you saw us cutting pipe 2. Then with all of the same settings, I cut pipes 2B and 2C in order to understand the repeatability. And then I don't know if I had mentioned this before, but I really didn't like the amount of dross that I was getting at the 45 inches per minute that I was cutting. So I ended up increasing the speed of the cut from 45 inches per minute to 90 inches per minute. And the results of that are what you're going to see at the end. I'll show you how that affected the dross. But for now, let's go back and let's take a look at each one of these pipes and the measurements that we've got, and see if we can draw some conclusions. As you may recall early in the video, I had mentioned that the way I had measured the pipe at my desk using the calipers was not exactly the most accurate way to measure these pipes. And the reason for that is that there are irregularities on the surface which will change the dimension depending upon where you take the measurement. Now we're talking thousandths or tens of thousandths of an inch, but still, when you're trying to do this, getting it right is, or at least averaged, is advantageous. So what I did is I went over to the vise on my milling machine, and yes, I should be ashamed of myself for how dirty that is. I get it. But I put these pipes in the vise and took measurements of the inside of the jaw in order to get a much more accurate idea of how long each of these pipes is. And so doing this is the same pipe that you saw before that we measured at, I think it was 2.86 inches or something like that. Now we're taking a look, and the measurement is 2.944 inches. After making the change to the kerf width in the Mach 3 screen set, we cut pipe number 2, and as you can see, the cut length of pipe number 2 is 2.9905 inches. The cut length of pipe 2B is 2.9975 inches. The cut length of pipe 2C is 2.9915 inches. And then the cut length of the pipe that we did at 90 inches per minute, that came out to 3.0195 inches. So as you can see, increasing the speed of the cut does affect the kerf. And, to the degree that you need to be, closer than like a 32nd of an inch in your measurement, you might want to recalibrate the kerf each time you change parameters. That's really up to you. Okay, so what does all this mean? Well, we started off trying to cut a pipe to 3 inches in length. We had an initial kerf entered in for the machine of 0.041 inches. That cut with that kerf resulted in a cut length of 2.944 inches. So we added 0.04 inches to the initial kerf, which adjusted the kerf to 0.018 inches. So the delta there is 0.04 inches. And we ran it through, and the difference between the first cut and the second cut, we were trying to increase the length by 0.04 inches. By 0.04 inches, we ended up increasing the length by 0.0465 inches, which that's okay. So then we ran the test again 3 times, or we ran it 2 more times, and we came up with the average length of our part to be 2.9932 inches, which is about 7 thousandths of an inch short of 3 inches. That's In fractions, that's probably one over 128th of an inch. So, you know, what it demonstrates is that we can get pretty accurate. And the great part about the machine is you really don't lose that accuracy over a lot of length. So that you know, that 7/1000th of an inch that we're off, you really, you know, you should expect to be pretty close to that in terms of how far you're going to be off, no matter what the length of the pipe is. And then the third interesting thing that we saw from this exercise is, you know, cut 3 ends up being longer, but still, you know, very close. That's, that's about a 64th of an inch from the overall length. Personally, I'd prefer to be a little bit longer than a little bit shorter, because you can always touch it with the grinder in order to bring it down to the length that you want. And so, you know, when we sped up the machine, we did affect the kerf. We did not affect the kerf enough here where I would go back to try and calibrate anything again. And I think that would be your experience too. But, you know, if you do make changes, you know what to do now in order to dial it in as close as you could possibly dial it in. So earlier in the video, I had shown you, or, you know, I had told you that I didn't like the way that the cuts looked at the 45 inches per minute. I'm just going to take a moment here at the very end and just show you a little bit of a video which shows the differences in the dross that you get, you know, between cut 2C, I think it is, and cut 3, or to put it in a different term, between 45 inches per minute and 90 inches per minute. So here you go with that quick video. So I don't know if you can hear me over the air compressor, but so like I said, I didn't like the amount of dross that I was getting at 45 inches per minute. This is what we got at 90 inches per minute, which is a much better, you know, much better cut in terms of the amount of dross that you have to pull out. Now we got to mic this and see how it works out in terms of the length, whether or not increasing the speed has changed the length.